concepts that allows students to transfer their skills across concepts and across grades. To bring this principle of focus to life in the classroom, the standards require a shift in instruction. Because of increased focus within the standards, we must now prioritize content and focus where the standards focus, on the major concepts, rather than all of the topics currently taught each year. For example, the Common Core will have students focusing intensely on number and relationships in the early grades, where learning about place value and other initial concepts will later serve as the foundation for subsequent work in algebra. By focusing on these and other key mathematical concepts, teachers will be able to significantly narrow and deepen the scope of how time and energy is spent in the classroom. This is an important improvement over previous requirements, which emphasized covering too many topics without any depth. The Common Core state standards for mathematics are written in such a way as to link individual standards with groups of related standards, or clusters, and larger groups of related standards, or domains. As a result, we can focus on energy and time on clusters of standards rather than a checklist of standards. We can then strategically consider how to support students in mastering core concepts that will lead to critical connections between concepts, across domains, and across grades. In your work with session facilitators, you will explore more deeply how these concepts are presented and explained in the standards. For now, let's look at a few sample problems and illustrations to see how classroom problems focus on the core concepts that lead to an understanding of place value and go deeper into the Common Core standards. In these traditional problems, students are asked to either identify the underlying digit or write the number when given the word name. Students who can solve these problems correctly must have an understanding of positional notation, or the location of each digit in a multi-digit number, and how it corresponds to a particular base 10 unit. By base 10 units, we mean ones, tens, hundreds, thousands, and so on. However, merely knowing positional notation does not imply that students have a deep understanding of place value. Positional notation is one aspect of a growing knowledge base. Students must also understand the additional aspects of place value and how they relate to each other. Look at the difference in these problems from the ones we traditionally see. Students similarly must have a sense of base 10 units, the relative size and relationship between units. For example, recognizing that 140 is also the same as 10 tens plus 4 tens, or 14 tens. Indeed, knowing how numbers are made or bundled and being able to unbundle them at will is key to demonstrating mastery of place value. Jason Zimba explains the importance of exploring the strategies of 10 in depth.
The strategies that are based around 10 are the most important. Finding partners of 10 and working around 10, replacing a problem with a problem that has a 10 in it, because those are the ones that are going to build place value understanding in early grades. So nothing against doubling plus one, use what you got, but just to make sure that that work it's going to feed into place value and computational algorithms later. And so 10 is a key number to work with on those things.
These problems, which can be explored more deeply with your facilitator, ask that students master certain core concepts and how they relate to one another. Focus within the standards, in this example, means making sure that students understand base 10 units, how they can be bundled and unbundled, and how those concepts connect to the positional notation. Taking the time to explore these concepts individually, as well as how they are connected, will provide students with a solid foundational understanding of place value that allows them to make the connections between and across ideas in future topics and in future grades as illustrated on this chart. As you can see from this chart, focusing on place value allows students to develop a deep understanding of number and their operations. This is a deliberate flow of ideas that builds mathematical concepts gradually as students move toward algebra. The progression of fractional concepts builds from the first grade, where students learn to partition shapes, looking at halves and fourths, to where fractions are taught explicitly in grades 3 through 5. While students sometimes think of fractions as one body of knowledge, and whole numbers as a separate body of knowledge, the Common Core state standards emphasize that they are all related to each other. Connecting fractions to numbers is a process that is usually taught first by explaining fractions to be part of a whole. Jason Zimba explains how this concept is initially introduced.
So in third grade, 1 over b is 1 part of a whole that is in b equal parts. And that's a nice general statement. We could be talking about pizza, we could be talking about a lot of things. We could even be talking about that part of the number line between 0 and 1. That part of the number line, that portion of it could be our whole. And if it's in 4 equal parts, then one part of that, any given part of that has magnitude 1/4, and the number 1/4 is the number that's located at the end of that first interval. That's where a fourth is on the number line. It's part-whole reasoning of the same kind we use when we talk about pizza, but it is a special case of it that is geared toward making fractions numbers.
However, understanding fractions as numbers quickly extends beyond flowers, pizzas, and parts of a whole. Soon, the transition is made to teaching this concept using rectilinear models and the number line. For example, in this 4th grade problem, students are asked to locate numbers, including fractions, on the number line and compare whole numbers and fractions. In asking students to understand how these numbers relate to each other, the opportunity exists to explore these relationships deeply in class. Students can use their knowledge and expertise with whole number arithmetic and apply it to newly unitized objects. Think of unitizing as thoughtfully assigning a unit of measurement to a given quantity, such as a case of cola, which could be thought of as 24 cans, or 1 unit, 2 12-packs, or 4 6-packs. Jason Zimba explains this connection further.
And so what's newer, and this again is related to fractions as numbers and the theme of getting toward fractions as numbers, and I'm sure this is going to be less familiar, is to show why these two fractions are equivalent on a number line. The 3rd grade fractions already ask us to locate fractions on the number line, and we have to be telling one story about fractions.
By grade 5, students will be using multiplication to generate equivalent fractions and use common denominators to add and subtract fractions with unlike denominators. By focusing on core concepts developed in early grades and applying them to new problems and situations, students will be able to build that strong foundational knowledge and move forward with new ideas because they have a deep conceptual understanding of what has come before. In middle school, the Common Core state standards for math have students focusing on the domains of expression and equations and the number system. These domains eventually merge to inform students' understanding of algebra. Within these domains, the standards focus on specific progressions at the cluster level to enable students to think, practice, and integrate each new idea into a growing knowledge structure. For many of us, shifts like the ones in these next examples will be confirming. For others, the shifts will mean paying more attention to underlying concepts. Jason offers additional guidance.
Thinking about the content standards at the cluster level is often a very helpful grain size to work because it doesn't drive you to an individual standard, and sometimes individual standards might be extremely important enough to call out and discuss in professional development or important to spend a lot of instructional time on. But the cluster level is helpfully concrete. You know, it's smaller than the domain, but also large enough to where it doesn't drive us to atomization unnecessarily.
We now invite you to meet with session facilitators. Discuss the problems presented in this video, as well as additional problems that illustrate how the Common Core state standards for math focus on core concepts. You should also discuss as a group the concept of time and where you think the standards offer an opportunity to prioritize content.